Hey everyone, welcome back to Science by Asha Matpal. Today I will be continuing with the class 10 syllabus and I have started with the chapter Chemical Reaction and Equation. In my previous session I have already given you introduction of this chapter and we have understood till the point that what are chemical equations. So let's begin today's session. But before I start my session, I would like to request you all to kindly subscribe to my channel and share it among your friends and family. So let's begin today's session. Now, in the chapter, we have understood till the word chemical equation. Now, in my previous session, I have told you that whenever we are writing the full chemical reaction, like for example, magnesium is burning. Okay, so this is a line, this is a statement, right? So one way is to write like this: magnesium is burning. So magnesium plus oxygen, right? Like this you can write, and it gives magnesium oxide, right? Now whenever we are writing the reaction, the full statement of a chemical reaction in the words, we are picking up the main words, then it becomes a word reaction, okay, or a word equation, right? Now the same thing can be written using a symbol. Okay, this one we have already understood also. Mg plus O2, the symbol of magnesium is Mg, the symbol of oxygen is O2, gives us magnesium oxide. So this becomes chemical equation. This becomes chemical equation. Okay, so there is a difference in word equation and in chemical equation. Okay, they are obtained from a chemical reaction. Chemical reaction is what? The full sentence: magnesium ribbon is burning with oxygen. It burns with a dazzling light and it produces a white powder, magnesium oxide. Now when we are picking up the main words and we are showing it with the help of the plus symbol and the arrow between the reactants and the products, it becomes a word reaction. And when the same thing is written taking the symbols, then it becomes a chemical equation. So till here we have already understood in my previous session. Now in today's session we will try to understand more about a chemical reaction and what are balanced chemical equation and how we can balance them. So let's start it. So basically this is again the same chemical equation definition I have mentioned here. A chemical reaction in terms of symbols, okay, and formulae of the different reactants and the product is called as a chemical equation. Okay, now how to write a chemical equation? The same thing is here, that we will pick up the symbol and the formula of the reactants, and they are always written on the left hand side, that is this side of the arrow. Okay, the symbol and the products are written on the right side, that is here it is MgO. Okay, and then we put an arrow sign between them, okay, pointing from the reactants to the product side. So here I have mentioned one example also. Okay, zinc plus H2SO4, zinc plus H2SO4 gives us ZnSO4 plus H2. So this is a chemical equation which is telling us that zinc reacted with sulfuric acid and it produces zinc sulfate and hydrogen gas. So this whole statement is chemical equation. What I have spoken just now, that is a statement. From the statement, when we are taking up the reactants and the products and they are getting mentioned in the terms of the symbol or the formula, it becomes chemical equation. Now for writing a chemical equation, there are certain things, okay, which you should be aware of. Those are valency and atomicity. Okay, so let's move towards to our next slide. That what should be the basic information with you for writing the correct formula and the symbols basically. Okay, so here you can see this is all you have learned in your class 9th syllabus you have learnt about the valency. So you should be aware of the valency of the first 20 elements for the class 10th syllabus. In the class 10th, elements from 1 to 20 atomic number are important. So you know that valency of hydrogen is 1. Just concentrate on the valency column. Okay, it is 1. Helium, it is 0. Lithium is 1. Beryllium is 2. Okay, and so on. Basically, with the help of valency you can form the correct formula of the compound. Okay, another thing which is very much important is this, that you should be aware with the radicals and their valency. Okay, there are some easy ways also to remember them or to recall them. Okay, I'll tell you some of the few ways. For example, whenever you are going inside the lab, okay, you must have seen on the bottles HCl is written, on some bottle H2SO4 is written, on some K2SO4. Then we are also having HNO3 in the labs. Then you can say another very common one you can take here, like for example NH4OH. Okay, so these are some very common items in the lab. Okay, and over the bottle you must have seen these symbols. Okay, if you are remembering these symbols, it will make your work little bit easier in terms of remembering the valency of the radicals basically. Now remember, always in class 9 you have learned that the valence in a compound, for example I'm writing here any compound. Let us say, suppose I want to make a compound between H and Cl, and I also want to make a compound between you can say Zn and SO4. Okay, so what I will do, at their foot or at their bottom I will be writing their valency. For example, valency of hydrogen is 1, valency of Cl is 1. Right, now valencies always goes to their neighbors. Okay, they always goes to their neighbors. So now one will go to H and one will go to Cl. Okay, now here you have to remember that whenever valency is 1 or is same, whenever value of valency, value means here I'm saying the number, right, is same, it is not shown, it is never shown. Okay, clear? Whenever the value of valency is same or 1, it is never shown. So here it is H1Cl1. Okay, but we will not write 1, we always write HCl. Why? Because 1 is never shown. Similarly, if you go to ZnSO4, valency of zinc is 2 and SO4 is 2. So this 2 will go to Zn and this 2 will go to SO4. So ideally it will become Zn2SO4 whole twice 2. Okay, but since valency are same, that is valency of zinc and SO4, valency of zinc and SO4 is same, so we will not mention it. Remember, whenever valencies are same or it is 1, it is never written in the compound. So what we write always? We always write ZnSO4 because they both are having 2 valency, so then we will not mention it. But there are another conditions where we show valencies. Okay, for example, hydrogen and oxygen. Hydrogen valency is 1, oxygen valency is 2. This 2 will go to H, this 1 will go to O, and it will form H2O. Right, so valencies are always mentioned when they are opposite or they are not having the same or the one value to them. Okay, and valencies always goes to their neighbor. Now coming back to the topic, these are the common reactants which you are seeing in the lab. Right, now here in this case you can see that HCl is mentioned over the bottle. Most of us remember that hydrogen valency is 1, right? So nothing is written at the foot of the Cl, okay, and nothing is written at the foot of H. It means what? Either the valency is same here, okay, or it is 1. Now you know that hydrogen valency is 1, so it means HCl, in HCl the Cl valency is also 1. So in this way you can remember. See here, you can check it. The Cl valency is 1. So this is a very easy way and a smart way to remember the valencies of the radicals also. Like for example here, see NH4OH. Now you know that NH4 is a radical and OH is also a radical. Like see here, NH4 here and then OH. Okay, now OH valency is 1. Most of us can remember it, okay, through NaOH compound. Through NaOH compound we can remember that. Okay, let me get some space here. So through NaOH we know that OH valency is 1, and most of us remember that its valency is 1. So if in NH4OH OH valency is 1, valency mostly remains the same, okay. NH4 is a radical and it is not having any valency at its foot, right? Similarly, at the foot of OH also there is no number. Okay, so it means what? That either the valency is same or it is 1. So here we can see that NH4 valency is 1. Why I am so much sure? Because we know OH valency is 1. That is why NH4 will also be 1. That is why it is not shown here. Okay, now if you go to H2SO4 here, okay, now see at the foot of 2 is, sorry, at the foot of H 2 is mentioned. Okay, this 2 belongs to SO4, so valency of SO4 is 2, right? But there is nothing at the foot of SO4. It means H valency is 1, which is right. You can see here SO4 valency in this chart is 2 here, right? Now similarly here K2SO4, this 2 belongs to SO4. Valencies always goes to their neighbors, right? So SO4 valency must be written at its neighbor's foot, that is at the foot of K. So it is telling us that SO4 valency is 2, and obviously nothing is written at the foot of SO4. It means what? That K valency is 1. Now you can check it here in this one, in this chart. I'm not able to point it. Now you can see here this one, potassium valency is 1, right? Okay, so in this way you can remember. Now see again HNO3, coming to HNO3. Now nothing is written at the foot of H. Okay, there is nothing which is written at the foot of H, right? It means what? NO3 valency is 1. NO3 valency is 1. You can check here. Now see the second one here. NO3 valency is 1. Fine. Now what if NO3 valency is 1, H valency is also 1. So that is why nothing is written at the foot of NO3 also. So in this way you can learn or you can remember valency of some of the elements as well as the radicals, but you will have to remember it for writing the correct compound, because if the correct compound is not written in a chemical equation you won't be able to balance it, okay, which is our next topic. Okay, so that is why remembering valency is very much important along with atomicity. Okay, atomicity is what? That whether the element occur as a single atom or not. Remember, most of the gases occur as diatomic. Their symbol is diatomic in a chemical reaction. For example, if you see here in this table, okay, argon and helium reactions are not asked basically, but you see oxygen is what? Oxygen here is diatomic, so you are going to write O2. Like for example, carbon is burning with oxygen. What we write? We write C plus O2. Why? Because oxygen always occurs as diatomic atom. If you will write C plus O, you won't be able to form the compound and you won't be able to balance it. Okay, so that is why atomicity is important. Hydrogen means you will always write H2 because hydrogen also occurs as diatomic. Nitrogen means N2. Chlorine means Cl2. Okay, like that. These are some common which I am telling you. Sulfur is polyatomic, that is more than one type of atomicity is seen in case of sulfur. Now coming to the monoatomic, sodium means Na you will write only, mono means it occurs as a single atom, iron occur as Fe, then aluminium occurs as Al, copper occurs as Cu, then you can say zinc always occurs as monoatomic, so you write zinc in a chemical reaction. Then magnesium always occur as monoatomic, so we always write as Mg in a chemical reaction or in a chemical equation basically. So that is why we need to be aware of valency as well as atomicity of some common elements and also of some common radicals. Radicals you can easily remember by thinking about some of the reactants which you have seen in the lab. Okay, let's move ahead in the chapter and we will be going to the chemical equation topic. Now, what is an unbalanced chemical equation? Now see, in a chemical equation there are two parts. This is the reactant side, right? This is a reactant side and this is a product side, right? So this is a reactant side, this is a product side. On both the sides we will have the same elements because these elements and their atom are undergoing chemical reaction and they are only forming the compound. Okay, now see, elements are what here? Here we are having zinc, so you are writing Z in here. Then you are seeing H, so element is H here. Then there is Cl, so you will be writing Cl here. Okay, now in reactant you see how many atom of zinc are there. See, always you will have to see that what is the number which is present at the foot. Okay, so zinc is having nothing written at its foot. It means that there is only one atom of zinc here, okay, in the reactant. Now in HCl, if you see the foot of H, okay, at the foot of H nothing is mentioned, there is no number which is written, so H is also 1. If you see the foot of the Cl, at the foot of the Cl also nothing is there, so it is also 1. Okay, now coming to the to the product side, if you see in the product zinc, nothing is written at the foot of the zinc, that is the number of atom of the zinc is 1. If you see Cl, at the foot of the Cl 2 is mentioned, so in the product the Cl is having 2 atoms. If you see H2, at the foot of H number 2 is mentioned, that is it is having 2 atoms in its product. Now see the number of the atoms in the reactant side and in the product side. If it is not equal, if the number of atoms are not equal between reactant and the product, then it becomes unbalanced chemical equation. Okay, now you can see here zinc atom is 1, product it is also 1, so zinc is balanced. If you see H, reactant side 1, product side 2, so H is not balanced here. And then Cl, it is 1 in reactant and it is also 2 in product. So H and Cl are not balanced, that is the number of atoms of H and Cl are not balanced between the product and the reactant. Okay, so this is an unbalanced chemical equation. Okay, they are not balanced, so they are not equal, it means that they are not balanced, so it becomes an unbalanced chemical equation. So an equation in which the number of atoms of different element is not equal on the two sides of the equation is called an unbalanced or skeletal equation. Okay, so in this way it becomes unbalanced, and such an unbalanced equation is also called as the skeletal equation. Okay, now we will be seeing that what is a balanced chemical equation, and then after that I will be giving you few examples that how we can make it balanced. Before going to that topic, if you see here, see if you see reactant, it is zinc plus HCl, right? But in the product, what we have written, ZnCl2. So how we have formed this compound? ZnCl2. This work you can do in the rough itself, okay? You will take the elements Zn and Cl. Then zinc valency is 2, Cl valency is 1. The valencies goes to their neighbor, so 1 will go to zinc and 2 will go to Cl. So it will become ZnCl2. Okay, so in this way you will be forming the compound. That is why I am saying that knowing the valency and the atomicity is very much important. So you will be able to form the correct compound. ZnCl2 plus hydrogen means H2. Hydrogen is a diatomic. Okay, hydrogen is diatomic, and an easiest way is to remember that most of the gases are diatomic, H2, Cl2, O2. Okay, like that you are going to write. So that is atomicity. Here why we are writing only Zn and not Zn2? Because Zn is monoatomic, that is why we are writing Zn. Okay, then this is hydrochloric acid, HCl. That is H combines with Cl. H valency is 1, Cl valency is 1. So this one will go to H, this one will go to Cl, and it will become HCl. Since valencies are 1 and they are same, so they are not shown. Okay, so it will become HCl. So that is why I am telling you that remembering valency and atomicity will help you in writing the correct chemical equation. Once you are able to write the correct chemical equation, then only you will be able to balance it. So let's go to the next topic, balanced chemical equation. Okay, now balanced chemical equation means when the number of atoms on the reactant side of a particular atom or element is equal to the number of the atoms of that element in the product side. So again, see, this is a equation where zinc reacts with sulfuric acid to give us zinc sulfate and hydrogen. Okay, now Zn is element here, then we are having H here, okay, then we are having S, and then we are having O. Okay, I always prefer to take one element, okay, not together as a radical. Like for example, in some books you will be finding that SO4 will be taken together there, okay, because it is a radical SO4. Okay, that is also a way. Now in the reactant side, count the number of Zn. Zn is 1 only because nothing is written at its foot. Then H2, H is 2 here, see. So H you will write 2 here. Nothing is written at the bottom or the foot of S. So you will be writing here 1. Then O 4. Okay. Now going to the other side, product side. Nothing is written at the foot of Zn. So it is 1. Nothing is written at the foot of S. So it is also 1. O is 4 here, so I am writing 4 here, and H is 2 here, so in front of H 2. Now you see that on the reactant side and the product side, the atoms of each element is same. For example, zinc is 1 in reactant, it is also 1 in product. H is 2 in reactant, H is also 2 in product. S is 1 in reactant and 1 in product. O is 4 in reactant and it is 4 in product. So all the elements have got same number of atoms on both the side, that is the reactant side as well as on the product side. So it's called as a balanced chemical equation. So coming to the definition, an equation in which the number of atoms of each element on the two sides of the equation are equal is called as a balanced chemical equation. Okay, this equation you can easily balance also, but remember, if you have not made the correct compound and if you have not kept the atomicity in mind while writing this whole chemical equation, you will never be able to balance it. So I'm saying again that always keep in mind the valency and the atomicity while making a chemical equation. Let's go to the examples that how we can make a chemical equation balanced. So this is one example here. Okay, KClO3 gives us KCl plus O2. Okay, basically it gets broken down into KCl and O2. Okay, now count the number of atoms. Okay, first of all list out the elements. So here first one I'm seeing is K, potassium, then we are having Cl, chlorine, then we are having O, that is oxygen, right? Obviously whatever is on the reactant side, that same thing will be in the product, because whatever you mix you will get in result that particular thing only. Okay, so in the reactant count the number of atoms. Now see, at the foot of the K nothing is mentioned, so it is 1. Okay, at the foot of Cl nothing is mentioned, so it is 1. Okay, O, at the foot of O 3 is mentioned, so it is 3. Now coming to the product side, nothing is written at the foot of K, so it is 1. Nothing is mentioned at the foot of Cl, so Cl it is also 1, and O this side it is 2. So now as you can see that this equation is an unbalanced chemical equation, because the number of the oxygen atom on the reactant side and the product side are not equal. So we will try to make it equal. Okay, that is called as balancing of chemical equation. Okay, now for balancing of chemical equation we always take the multiples of 2, 3, which are very common. Okay, multiples of 2 or 3. Okay, and you will have to keep in mind that you can write number, okay, 2, 3, 4, 5s, okay, only in front of the symbol, in front of the symbol. Okay, symbol can be of an element or it can be of compound. Fine. So now you are seeing here it is KClO3. I'll write here KClO3 gives us KCl plus O2. Okay, now we want to make the oxygen atom balanced. Okay, mostly we start with the table of 2. Okay, so for example, if I want to put a number, I will put in front of the symbol. Okay, that is O. This is one I have written here. You cannot write any number here, remember. Okay, why? Because at the foot always the valencies are mentioned. These compounds are formed using valencies, so we will not change the valency. We cannot change the compound, remember. You always put number in front of the symbol, whether it is of element or of the compound. So to make oxygen balance, I am starting with the 2. So now here this number which is written in front will multiply with the number which is at the foot. So it will become 2 into 2, 4. So here in the product side the oxygen atom are 4 now. Okay, fine. Now if I will write 2 here, because here it is 3. Okay, if I will write 2 here, then what will happen? This 2 will become common for all of them. So K will become 2 here, Cl will also become 2 here, and oxygen will become 2 into 3, 6. It will become 2 into 3, 6. Okay, I have told you now, whatever number is written in the front, it will multiply with the number at the foot. So at the foot of oxygen 3 is mentioned, so this 2 will multiply with the 3 for oxygen only, because at the foot of K and Cl only 1 is there. So 2 into 1 will be 2 only. 2 into 1 for the Cl, it will be 2 only. Okay, so by writing 2 in front of KClO3, K will become 2, Cl will become 2, and O will become 6. Still our problem is not solved, because this side K is 1, Cl is 1 and O is 4 by putting this 2 here. Right. So now what we can do? We can change the number. Now see, it is 6 here. Okay, and this oxygen is alone, so you can simply put 3 here. Okay, 3 2s are 6, 3 2s are 6. So here oxygen will become 6. So now oxygen will be balanced by putting 3 here. Okay, now what about K and Cl. They both are 2 in the product side by putting this 2 here, but in the K and Cl are 2 in the reactant side, but they are 1 in the product side. So what we can do simply that we can put 2 here. Okay, so K will become 2, Cl will become 2, and this equation will become balanced. Okay, so how we can make it balanced? We will put 2 here, so it will be 2 into 3 6. So here we were putting 3 into 2 6. Okay, this 2 will go to K also, so we will put 2 here, and this 2 will be of the Cl also, so here also it will be of Cl. So now the changed one I am writing. Okay, this one is cancelling. Here it is 2, here it is 2, here it is 6, and here also they all will change. Okay, they will become 2, 2 and 6. Okay, and in this way it becomes a balanced chemical equation. Just remember, you cannot put any number at the foot of the symbol or the compound. Whatever number 2, 3, 4, 5 you want to put, it will always be put in front of the element or the compound symbol. Okay, you cannot put at the foot, because those are the compounds or the elements which are mentioned there on the basis of their valency or their atomicity. So we will not be changing that. Always put number in front. Okay, and if any number is written at the foot, the front number will multiply with it. Okay, so now let us take another example. Now this is another equation. Okay, Mg3N2 plus H2O gives us MgOH whole twice plus NH3. Now first of all mention element Mg, then here N, then H and O. Okay, now count the Mg. Mg are 3 in the reactant side, mention 3. 2 is written at the foot of N, so write 2 here. H, it is 2, and O, at the foot of O nothing is mentioned, so it is 1. Right, now coming to the product side, this Mg foot nothing is mentioned, so Mg is 1 here. Now OH is inside the bracket, and outside the bracket the number 2 is mentioned there. Okay, this 2 belongs to both O and H. Okay, it is whole twice kind of thing. Okay, so 2 goes to O also and H also. So here O is also 2, sorry, it is 2 here, and H is also 2. N is here, at the foot of N only 1 is there. Okay, that is nothing is there, so it will become 1. And now at the foot of H 3 is mentioned. Okay, so 2 plus 3, so it will become 5. So this is an unbalanced chemical equation where all the atoms of every element are unbalanced. Like Mg, it is 3 in reactant, in product it is 1, N it is 2 in the reactant and 1 in the product, H is 2 in the reactant, 5 in the product, O is 1 in the reactant and 2 in the product. So it is again an unbalanced chemical equation. So let us see how we will be able to balance it. Again I am doing the rough work here. Okay, this is for your understanding. Basically MgOH twice plus NH3. Okay, now see Mg is 3 here. Okay, so let us put 3 here. So Mg will become 3 here also and here also. Okay, but this will go with this one 2 here. So 3 into 2 6. So O will become 6 and H will also become 6. So how we can do it? We can put 3 here. 3 2s are 6 H. Okay, but O is still here 3. Okay, so this is like we just cannot put 3. Okay, cancel it. Then we are having NH3. So N is 2 here and here it is 1. So let us put 2 here. So N will become 2. But there are 6 H here. H is 6 here, and here also H is 6. Okay, 3 2s are 6 and this 6. So in the product side total we are having 12 H. Okay, and here we are having 2H. So if we put 6 here, 6 into 2, 12, H will become 12 and O will become 6. And here also O is 6, 3 into 2, 6, and the 6 is also for the oxygen, right? So if we are putting 6 here, okay, 3 here and 2 here, okay, then it becomes a balanced equation. Now Mg3 in the reactant, Mg3 in the product, okay, in the product also. Now O is 6, 3 into 2, 6 here, and here also it is 6. So O is 6 here, and here also it is 6 now, okay. N is 2 here, here also N will become 2, okay, right. Then H here it is 6 into 2, 12, and here 3 into 2, 6, and this 6 will go to H, so here 6, and here also 3 2s are 6, so it will become 12, right. So H will become 12 here, and here also it will become 12. So you now now you can see that Mg is 3, N is 2, H is 12, and O is 6. So on both the sides of the equation, the number of atoms of the reactant and the product side are equal. So this is a balanced chemical equation. Okay, so just keep in mind the simple multiples, okay, and you will be able to balance it. Now let us take another example. Okay, now see this one. CaCO3 plus HCl gives us CaCl2 plus H2O CO2. All these compounds are formed using the valency. Keep in mind, for example, CaCl, okay, Ca valency is 2, Cl valency is 1. So 2 will go to Cl and 1 will go to Ca. So compound will be CaCl2, okay. If the compound is written correctly, okay, and the symbols are also mentioned, okay, correctly, keeping in mind their atomicity, then it becomes very easy to balance a chemical equation. Now here CaCO3 plus HCl. Obviously first thing is to list them out. Ca is there, then C is there, O is there, then H is there, and Cl is also there. Now count. Ca is 1, nothing is written at the foot, so Ca is 1 here, okay. Then at the foot of C nothing is mentioned, so C is also 1. At the foot of O 3 is there, so you will be writing 3. At the foot of H nothing is mentioned, so it is 1. At the foot of Cl also nothing is there, so it is 1. In the product side, Ca is having 1, okay. Cl2 it is 2, it means, okay. H is 2 here, so H you are going to write 2. Then O is 1 here and 2 here, so 2 plus 1 3, okay. And C is 1, right. So this is a unbalanced chemical equation. We will try to balance it, okay. Now what we will be doing, we will be again starting with the simple symbols, okay. That is the simple numbers we will be putting, very simple multiples. Ca is 1, Ca is 1 here, keep in mind. Cl2 is 2 here, and it is Cl only here, so in front of it there is a, we can put 2. This 2 will go to H, this 2 will go to Cl, so Cl will become 2, right. This will become Ca is 1 here, okay, and H will become 2, H is 2 here, okay. So Ca, Cl and H are balanced now, okay. Oxygen is 3 here, okay, and here also 2 plus 1 3, and C is 1 here and C is 1 here also, okay. So it has become balanced, okay. Just putting 2 here, it is completely balanced, okay. See, Ca is 1 here, Ca is 1 here, okay, check, right. Then Cl2 is 2 here, also Cl2 is 2 now, okay. So it is also equal. H is 2 here, H is 2 here, okay. So it is also right. and Ca and O are already equal. So in this way it has become a balanced chemical equation. Now let us take another example. Okay, now see this one. Sodium carbonate reacts with hydrochloric acid to gives us the sodium chloride, water, carbon dioxide. So again we'll start with listing the element Na, C, O, H and Cl. Okay, now in the reactant Na2, C is 1, O is 3, H is 1, Cl is 1. Okay, Na is 1 here, Cl is 1 here, H2, H is 2 here, okay, and O is 3, this O plus this 2, so 2 plus 1, 3, okay, and this C is 1 here. Okay, so basically we are seeing that H is not balanced, okay, and Na is also not balanced. C, O and Cl are balanced. Okay, so we will start with H. Okay, here if we are writing 2 here, then this 2 will make H also 2, okay, and Cl also 2 here, right, but here the Cl is 1. So how about we put 2 here, the Cl will become 2, okay, and Na will become 2. Now see, Na is 2, check, right, in reactant product, okay, it is equal. In C also it is equal. In O also 3 3 on both the side, it is equal. In H also it is equal on both the sides, and Cl also both the sides. Okay, so by simply you will have to keep a track, okay, in the reactant and the product side you can do it. If you will keep on doing more and more practice, you can straight away balanced an equation. There is no need to do any kind of rough work. Just keep pencil and rubber handy with you and you can try it out. Now let us take another example, AgNO3 silver nitrate, okay, plus NaCl plus AgL plus NaNO3. Remember all these compound NaNO3, AgCl, AgNO3, they all are formed using the valency. Okay, like for example AgNO3, okay, the valency is 1 here and it is 1 here, so it is AgNO3 simply. Okay, so likewise these compounds are formed. Na valency is 1, NO3 valency is 1, that is why it is NaNO3. Cl is 1 here, Ag is 1, so it is AgCl and so on. Okay, now always write elements under element column, N, O, then we are having Na and we are having Cl. Okay, Ag is 1 here, N is 1 here, okay, O is 3 here, Na is 1, Cl is 1. In the product side, Ag is 1, okay, Cl is 1, Na is 1, N is 1 and O is 3. So it is already a chemical equation which is balanced, so there is no need to balance it. Okay, so keep in mind that if it is like sometimes it is asked also blindly like that, so it is a balanced chemical equation, no need to put any number simply. Then let us try with another example, this one. Okay, barium chloride reacts with sulfuric acid to give us barium sulfate and hydrochloric acid. Okay, now barium, Ba symbol, then Cl, then H, then S and then O. So reactant side Ba is 1, Cl is 2, H is 2, S is 1, O is 4. In the product side it is 1 here, then S is also 1, O is 4 and H is 1 here and Cl is 1. Okay, right, so in this way what we can see that they are not balanced. So what about we put 2 here simply, so H will become 2 and Cl will become 2. In this way it becomes a balanced chemical equation. So with time you will also become very quick in balancing it. Now coming to the part, this is all about the practice, that more you practice you will be able to do it very fast, the balancing of the chemical equation, and it is a very important part of the board examination also. Now why there is a need to balance a chemical equation? Okay, see, you have done the law of conservation of mass. Okay, so to fulfill that law, or according to that law, the number of atoms on the reactant and the product side should be same, because what the law says, that nothing is created or nor it can be destroyed, remember. So whatever is here, it remains here only. So the number of the atoms on the reactant side must be equal to the number of the atoms on the product side. So that is why there is a need to balance a chemical equation, just to satisfy the law of conservation of mass. That is, the total mass of all the product must be equal to the total mass of all the reactants. Okay, now what we can do to make it more informative? Okay, we can make a chemical equation more informative by mentioning the physical state. For example, I'm saying hydrogen reacts with oxygen and it forms water. Okay, so now oxygen, hydrogen is a gas here, so in the bracket we can write, okay, like this, and water is a liquid, L we can write. Okay, sometimes we also mention the concentration of the acids. For example, you can write that zinc reacts with dilute sulfuric acid. So sulfuric acid formula is H2SO4, but I have said what, dilute, so either I'll mention it here or I will write here DIL. Okay, DIL only we write. If it is concentrated, we will write CONC. Okay, concentrated means full strength one. And then heat changes, like for example in some of the reaction we say the heat is evolved. Okay, for example, X reacted with Y and it forms XY. Along with it, the heat is evolved. So what we do, that we make a symbol like this, the upward arrow. Okay, or we can also mention it some other way. So this is the heat changes. Then conditions, coming to the condition point. Now condition can be the pressure condition. Okay, we mention it in the terms of atmosphere there. Sometimes we mention conditions like temperature. Okay, it is mentioned in degree Celsius. Sometimes we also mention a catalyst. Now what is a catalyst? Catalyst is a atom or any kind of uh, material substance which can increase the rate of the reaction. Now rate of the reaction means to say that it speeds up a chemical reaction. Okay, it does not get involved, it speeds up only. Okay, so like common catalysts are nickel, platinum, so we just mention their symbol over to the arrow. I'll give you one example here. Then we also like for example pressure, temperature, catalyst, along with that we also mention heat. Okay, heat symbol is triangle. Okay, so it is also mentioned over to the arrows. And even sunlight also we mention in some of the reaction. Okay, in the photolytic reactions we mention the sunlight, and we also write this kind of symbol over there. For example, I'll give you one conditions under which the reaction takes place example there. You can write simply, like for example we mentioned that CO plus we can write H2O combines and it gives us CH3OH. So on the arrow we write the conditions. The conditions you can mention there is like for example 300 atmosphere. Okay, and you can also mention the presence of the temperature 300 degree Celsius and so on. So they are always mentioned over to the arrows. Okay, so in this way what we are telling that under the under these conditions this chemical reaction is occurring. Okay, so basically whatever we are mentioning over to the arrow, whether it is heat or the temperature or the atmosphere, it is just telling that what are the conditions under which this reaction has taken place. So it is making our chemical equation more and more informative. Okay, so this is all for today's class regarding the chemical equation. In our next session, I will be explaining you the different types of the chemical reaction. Hope you are liking my sessions, and please share its link among your friends and family, and don't forget to subscribe to my channel. Thank you. Bye bye.